Hello and welcome, this is Edoreld, and in this episode of GregTech from scratch I will be showing you GregTech blocks that deal with redstone logic. Now first up we've got the button panel. The button panel is crafted by putting 16 buttons on either an aluminum hole or bronze hole, machine block or machine frame in an assembling machine, and it looks like this. Now on the other sides, this machine can output redstone, top, bottom, and three sides here. On this side you have 16 buttons, which you can activate individually. Now when you press a button, it's gonna emit a short redstone burst on each of its sides, output sides, but it won't stick. If you want the buttons to stick, you need to put a redstone machine controller on one of the other sides, and then when you press a button, it'll stay activated. Now each of the buttons represents a redstone signal of a different strength. Starting from the top left, you've got the first button, which is a redstone signal of 0. Then you move to the right, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the last one is the redstone signal of 15, which I'm using right now. Then you've got, let's press 7 for example, and you see how it changes. Now if you want to block an output from working, you simply screwdrive that side, and there you have it. The buttons are actually binary representations of the redstone signal they're emitting. The dark shades represent bits that are activated. Starting from the bottom right of a button, you count whether it's dark or not. So if it's not dark, it's a 0. If it's dark, it's a 1. So in this case, you got 0, 0, 0, 1. So you got the binary number 0, 0, 0, 1, which in decimal it's 1, and here it should be 2, 0, 0, 1, 0. That's a 2. And etc. And it'll be important to know this for the last block, the redstone circuit block, which uses some binary operations. Now next up we've got the redstone display. Redstone display is crafted with 6 refined iron or aluminum plates, 1 computer monitor, and 2 comparators. And you craft, it looks like this. It has 5 input sides and the main side here. Now depending on the redstone signal that you input, it's gonna display a different bar here. So let's input a redstone signal of 14, and there you have it. It filled up to the top and it left you with a red square. If we use a redstone signal of 12, it's gonna fill up a little bit less, and same with the redstone signal of 10. If we input a redstone signal of 15, it's gonna fill up to the top, plus it's gonna show you a green square. So it's an easy way to have a visual representation of a redstone signal. Last up we've got the redstone circuit block, which is crafted with 4 refined iron or aluminum plates, 2 comparators, 2 repeaters, and 1 circuit. And it looks like this. This machine actually accepts and needs energy to work. Now you want to make sure you block all of the sides you're not going to use, especially the side you're inputting energy from, in which you want to put a redstone cover, a red cover with a screwdriver. For the purposes of this tutorial, I'm gonna block all of the sides except for 2. And I'm gonna use button panels, because different redstone signals will do different things in here. Now if we access the interface, you got this GUI. You can switch functionality with the arrows to the right. You can left click to go one up, one forward, or you can right click to go back. The redstone button here determines whether you're outputting a redstone signal from the output side, which looks like this. The input sides look like this, so here you can see the difference. Now the timer is working, but I wanna configure it. I wanna have a timer of let's say 5 seconds, which would be 100 ticks. I wanna tell it to pulse 5 times, and I wanna tell it that the interval between pulses is gonna be of half a second. And measure in ticks. Length and delay is measured in ticks. Now I want the redstone here to be off, and that means that if it's not receiving a redstone signal, it's gonna work. So now let's see it in action. Every 5 seconds I'm gonna get pulses. The interval between the pulses is gonna be half a second, and then it's gonna wait 50 ticks, I think, without any pulses, and then it'll start the cycle again. So it's a highly customizable timer. Next up, we've got basic logic functionality. This block can emulate logic gates, or XOR, NOR, XNOR, and etc. Let's see AND in action. AND is a logic gate that will only output a redstone signal if the inputs are all on. So let's turn the inputs all on, and it doesn't matter what redstone signal you use. Oh, and let's put some machine controls here so the buttons stick. And there you have it. As soon as I turn all of them on, it starts outputting that signal. If I turn one of them off, it stops. And there's also the bit versions of these gates, which work a little bit differently, and you actually have to use the binary representations of the buttons. Now I got bit AND. That's gonna take whatever binary value of the buttons you press, and it's gonna perform an AND operation on those values. So if we press a button taking into account its binary value like 0001 here, and then we press another button like 0011, it's gonna do an AND operation on them. It's gonna result in 0001, which is 1 in decimal, and it's gonna output a redstone signal with strength of 1. And all of the all of the other operations work the same. Then we've got the repeater with a configurable delay. So you can just put whatever number you want. I'm just gonna put 40 ticks. I'm gonna turn off all the signals, which will take 2 seconds here to turn off. And then I'm gonna emit one signal, and after 2 seconds you'll get the signal out. So it's a repeater with a highly customizable delay. Next up, we've got the pulser. You can configure how strong the signal it emits is, and how long it stays on. So I'm just gonna configure it to stay a couple of seconds on. And now when I emit a redstone signal, it'll emit wait, let me turn off all of the inputs first. And there you have it, 1, 2, and it's off. So pulser emits one pulse, and then it turns off. Next up, the redstone meter. The redstone meter is used to measure whether a redstone signal that you input is between certain values. So let's say I put a lower value at 10 and upper value at 11. It's gonna say if the redstone signal you input is bigger or equal than 10, or smaller or equal than 11, then it's gonna emit a redstone signal of strength of whatever you want here. Invert would invert the whole operation and would say emit a redstone signal if it's not between these values. So any button I press that is not 10 or 11 will not emit a redstone signal. However, if we press 8, 9, 10, it emits a redstone signal of strength 15. 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There you have it. And 11 will also emit a redstone signal. However, 12 will not. If we say lower let's say 2 and upper 15, and we invert it, then it will only emit a redstone signal if we put a signal of 1, but any other value will not emit a redstone signal. And that's how it works. Next up, we've got the randomizer, which will emit redstone signals of random strength every how many ticks you specify here. So right now it will emit every 2 seconds a redstone signal of random strength, and the redstone needs to be off for it to work, because that's what it says. R is off. As you can see, every 2 seconds the redstone signal is changing, and that's what the randomizer does. Next up, we've got the combination lock, and the combination lock works like this. First of all, I'm gonna reduce the inputs to just 1, and I'm gonna say I wanna create a combination lock. These numbers go from 0 to 15, representing redstone signal strengths. I'm gonna set it to 3, for example, 7, 11 and 15, which are the numbers, the buttons on the right column. And now for this to emit a redstone pulse, I gotta press those that combination in order. So first I press 3, then I stop emitting a signal, so the system knows that it's ready to accept the second number. Now I emit 7, off, 11, off, and when I press the 15, it's gonna emit a redstone signal acknowledging that I've got the right combination. There you have it. And that's what the combination lock does. Finally, we've got the hardcode bit AND. The hardcode bit AND has 4 configurable settings: bit 0, bit 1, bit 2, and bit 3. You can turn them on and off, and it'll basically emit a redstone signal if any of the bits that you put on mode are on. So if I just have the first bit 0 on, then if everything's off, all bits are off, so it doesn't emit a signal. If I push the first button, it's gonna emit a signal because that's the first bit. But any of the buttons that don't have that first bit darkened, then it's not gonna emit that signal. As you can see, if I emit this one, it'll emit a signal. If I have bit 0 and 1, then if either one of those bits is on, it'll emit a redstone signal. But if none of them is on, then it won't emit. And that's how the hardcode bit AND mode works. And that's the last mode of this block. So those are the GregTech blocks that deal with redstone logic. I hope you enjoyed watching, and I'll see you next time.